Good morning, everybody, and welcome. I think I know many of you. My name is Tom Dennenberg, and it's my great honor and privilege to be the director of Shelburne Museum. We were just talking at the speakers table for a few moments about Shelburne Museum and about the symposium and this exhibition, this wonderful exhibition, Eyes on the Land. And we were talking about the strategic plan for the museum, and I explained basically what we're up to is we are re-enchanting, it was Stephen's term, re-enchanting Shelburne Museum, where we are bringing artists and intellectuals, public intellectuals, to the museum and making the different connections of our buildings and our collections, connections of our buildings and our collections for a broad audience. So I'm so pleased to welcome you all to this symposium this morning. If you'll forgive the pun, there's something underfoot in Vermont these days, and it is land. Eyes on the Land, this wonderful exhibition, which we organized with our partners, the Vermont Land Trust, is part of a broad movement which is very, very obvious when you look at all of the projects in the state which are taking up this question of the wonderful resource of land in Vermont. We, of course, celebrate the exhibition, celebrated it last week with the opening on Friday night. Our symposium today. I note at the same time the Burlington City Arts and Shelburne Farms have Of Land and Local up at just 3 miles away from us. Kathleen Kolb's wonderful project Shedding Land on the Working Forest is open at the Brattleboro Museum. Fur and Feathers, Feathers and Fur, Portraits of Field, Forest, and Farm at the Great Hall in Springfield. Land and Light and Water and Air at the Byron Memorial Gallery in Jeffersonville. The Vermont International Film Festival is screening Chester Grimes, which hasn't been seen, and those of you who know that short documentary of the gentleman who logs with horses is a wonderful moment in our history as well. This collective zeitgeist about land comes at a very interesting moment. The fact that all of these organizations in a vernacular way take up the topic at the same time through images, objects, and texts clearly tells us that there's something going on with our concern about land and landscape around us. The genesis of Eyes on the Land, I think like many projects in the state of Vermont, came in Brooks Buxton's kitchen about 2 years ago. At a dinner when Susan Abbott mentioned to me that she was putting an exhibition together for the Land Trust looking at creative responses to the stewardship of land. I was dumbfounded to learn and to be reminded that the Vermont Land Trust alone is steward to some 9% of the land in Vermont. 550,000 acres of working land, working farms. There are other organizations as well, at work in this field. So it's extraordinary to me that in this little state where we spend so much time thinking about the viewshed, that percentage of the land is in fact in trust. I'm very, very pleased at the format that Karen Peterson and her educators at Shelburne Museum put together today. For a number of years, I've thought the highest and best use of an institution like this is this process of re-enchantment. And the way we re-enchant our landscape and our museum is through hearing the voices of multiple creative practitioners from different disciplines. You are in for a huge treat this morning. We have speakers from around New England, and we have speakers from around the state. And it is my very, very great pleasure to introduce Robert Thorson to you. Robert is a professor of geology at the University of Connecticut in Storrs. He is the coordinator of the Stone Wall Initiative, a journalist, public speaker, consultant on geotopics, and the author of 5 books on stone walls, kettle lakes, and ponds. And his most recent work, Walden Shore, Henry David Thoreau and the 19th Century, and 19th Century Science, has just been reissued in paperback. Thorson's intent with this research is to smooth the divides among the scientific, historical, and literary academic silos. And he did just mention to me that as a geologist, his most recent book has been classified as literary criticism. That is exactly the conversation we want to have here at Shelburne Museum, and I would like to welcome Robert Thorson, to the podium this morning to kick us off. Thank you.
So if Vermont were a book, like this lovely book by Charles Fish, In Good Hands, Keeping of the Family Farm. I was smitten by this book about 15 years ago when I read it. So if Vermont were a book, then rock and soil and water and ice and humankind would be the chapters, and then you'd have a conclusion. Those are the key narrative links in the landscape that we have here. Leave one out and the others don't make sense. And like any good narrative, you have to start with the rock. Because you carve a landscape from something, don't you? It's carved, it's not built, it's carved away from a mass of something, which is rock. So it's analogous to a sculpture. You start with the raw block of marble, and you take things away, and you're left with the object of art. You start with a mass of rock, in this case, rock that is 10 miles down, vertically. Start with that rock, bring it to the surface, and the mountains that you see, in this case, the Green Mountains, they're not thrust up. They're what's left after everything else is taken away. So the landscape is carved from a raw material, which is rock. The agent of carving is soil, specifically a forest soil, without which you wouldn't do much work. That's analogous to the chisel of the artist. Water, that's the great sluicer. It's the vehicle by which we wash away the residues. In the case of an artist's studio, it would be the broom that would sweep the debitage away so that there would be room to keep working your way down to the core of that object that will ultimately become Vermont. And then you bring in ice. And ice is not the agent that creates your landscape. It's the one that embellishes it and smooths it and embosses it and puts on the finishing touches, if Lake Champlain can be considered a finishing touch. But it is at the scale of all of Vermont. And finally, setting the stage for the people who are working on the land or working the land or the working landscape, or the many ways we could think of this symposium being titled, Humankind puts the finishing touches on the finishing touches and gives it meaning, because there is no meaning without that humankind. Everything else is material reality. And we make the most of that material reality by understanding the pieces. So perhaps I should write a book about Vermont with these being the chapters, and then you read the narrative. And the end result is a greater appreciation of this fantastic state. This is a statue carved by nature, acid rain if you like. I believe it's from Dorset, Vermont. It's an object in a stone wall, and I call this object Marble Lisa, because it's definitely a carving, and to me it's female. But others look at it and say, you're biased. It's a male. It doesn't matter to me. I call it Marble Lisa. And I think you can see a smiling face. So the idea is that some pieces of this marble, right, are more resistant than others. A little more silica, a little more magnesium, whatever it is. And most of it is fairly soft. You know what I'm talking about on the marble tombstones. You know, they got that sugary dissolution. You can rub the grains off. Well, in this case, it's just a block of marble in a stone wall that's dissolving under the acid rains that we have. And it takes on this apparition. So thank you, Karen. That's you. Okay. And there are others. Can you see the others? There's a little guy here. You see? And there's one here. Look at that guy. See the nose? Tip of the nose. Smile right there. She has children. That is why I think it's female. Now, these pictures were taken yesterday, and I just love the one on the left. Believe it or not, that is your state tourism map, picked up at the Vermont Tourism Center in Brattleboro or south of Brattleboro. You know, that's for all those people coming up from the south, right? You know what I'm talking about. Well, that was me yesterday in the pouring rain. So we stopped at the Vermont Visitor Center and picked up the state map, and that's it. And the interesting thing to me is that it's tilted. You see how the posts are tilted? So we studied that diagram, and first I wondered, why would anybody, you know, in charge of the state map have a tilted covered bridge that looks like it's about to fall? The answer is it's not about to fall, because that's an optical illusion. When you look at something straight on, every visual artist knows this, it's out there, things slant away from your radial point of view. That is, there's a tilting up, a tilting down, a tilting left, and a tilting right. So what this means, if the vertical uprights are tilting to the right, it means the real focus of interest is over here. You see that? And so this is the right-hand edge of a photograph that somebody took. Does that make sense? So it makes me wonder, what is the real Vermont that's being left out in the left? And the argument here is that our sense of place question mark in Vermont is selective. We choose to reinforce certain things and not others. This one is a dichotomy, because if you look over here, you know why that spot is there? This is the picture that they put in my hotel room. That's glass, a reflection. And this is what they choose in Burlington on a hotel room to say, you have reached Vermont, you are in Vermont. And it's not the same image. This is basically a flatland, and you're lucky you have it, that entire plateau where more than a third of Vermont's population lives on the flat, gravelly, sandy soils, you know, of the delta that came out of the rivers to the east of here, built into Lake Champlain when it was higher. I mean, that's what the terrace on the University of Vermont is. It's one great big flat river delta, or terrace, edge, wave-cut shoreline, something like that. It's made of sediment. It's not made of rock. And it's vast, and that's where a lot of people live. And this is the carved residual over there, the Adirondacks in the west. I mean, it has to be to the west, can't be to the east. So how can that be a scene of Vermont? It's the foreground that we're paying attention to. That's flatland Vermont. So there's a dichotomy in Vermont. We love to think of Vermont as being the cozy little villages, the streams everywhere, most of the land in slope. Noel Perrin complains about that. Vermont's the place where all of the land is in slope. Well, it's not. You know, the biggest city is Burlington and South Burlington. The megalopolis that I'm in right now even extends as far as Shelburne. I drove this way through 1960s and 70s housing developments that looked like they could be in Indiana. You know, it's lovely. I mean, they're there, but the fact is, this is a small metropolitan area, and it's on flat land. And yet the image of Vermont that we're telling the tourists that arrive here is it's a valley bottom Vermont. I love Vermont. I think it's cool, and you'll figure that out later in my talk. I'm just trying to tease your brains a little bit. This is the way this particular geologist looks at the promulgation of the Vermont imagery to the tourist who goes to a Burlington hotel and who arrives at the visitor center. I'm probably already behind time, but this happens to be every time. So I actually have an outline of my talk. By the way, give me an end time, Karen, or boss. Yeah, give me a 10-minute warning, would you? Okay. Now, wait a minute, it was 40. Oh, 30 minutes left. There you go. Okay, I got to do sensing deep time. This is the topics, and of course, if there's time, that's my whole talk on stone walls in Vermont. We're not going to get there, but I'll get the rest of it. The symposium. What is the title of our symposium? The Working Land? I love this. In physics, you will learn what work is. Work is force times distance. Okay, some force times some distance. That's the true definition of work. So everything we think we know about work, and I know what work is, I work my buns off sometime, you know, to grade papers or to write a talk or to attend a meeting. We all know what work is, but fundamentally, work is force times distance. And this is the derailment you had last week. How lucky for me. right, in Northfield, Vermont, Boston Globe, October 5th. That's less than a week ago, okay? And I drove through Northfield on the way up here. So here's the Amtrak, and you know what happened? The boulders fell on the track and it derailed and 7 people went to the hospital. And so what's my first thought? The land is working to be itself. It's moving mass and distance. The land works in spite of us. That's my key here. It's not us working the land, it's the land working us. And that's the essence of Robert Frost's poem, The Gift Outright. The land is working us, even as we are working the land. Please change perspective. Please listen to my course mantra. Every course has the same mantra. No rock, no ecosystem, no culture. In Vermont, what does that mean? It means no Paleozoic tectonic melange, okay? No Ben and Jerry's, no Shelburne Museum. Because the Shelburne Museum depends on the dairy ecosystem. Otherwise, you wouldn't have a signature round barn, right? And that depends on the soil, and that soil depends on the rock that provides essence to everything, including the neurology in my brain that's going right now. And I love this one. It's one of the first pictures that I ever took in Vermont. It's an old railroad trestle, and I published it in Exploring Stone Walls. These are blocks fitted together very nicely, but they're already falling apart. Do you see that? And so to add extra support for this Vermont railroad trestle, and I forget where it is, they took the rubble and attached it next to it to help support it. I just love that. That's working to keep the landscape up in spite of itself wanting to fall apart and disintegrate. Eyes on the land or eyes of the land? I'm obsessed with Henry David Thoreau, and he's as good of an observer of work and science and literature and art and culture as anybody. And this is a Kettle Lake, and a Kettle Lake is the rounded kind of glacial sinkhole lake of which Walden is the most famous, Walden Pond in Concord, Mass., where I'll be speaking a week from now. That's the most famous one in the world. And Henry Thoreau says, a lake is the landscape's most beautiful and expressive feature. It is Earth's eye. And then he goes on and on and on about that. It is Earth's eye. So remember, the Earth is looking at us even as we have our eyes on the land. Now, no self-respecting geologist could give a talk on a sense of place without also invoking a sense of time. And so I'm going to read from Charles Fish's book, but I'm going to take it out of a now 13-year-old book, Stone by Stone. That's Some Vermont Byway, or Barway on a Byway, and I forget exactly where. And my writing followed by the quote, which is Fish's writing. In spite of their relative youth, old stone walls are ancient enough to help make the modern world seem more tranquil. They encourage us to slow down. Charles Fish, writing of his Vermont family farm, said, walking east on the edge of the pasture and stream, I come to the big rock meadow where an abrupt outcropping provides a place to climb and picnic. Even to my mind as a boy, the rock suggests permanence, or, as I will later think, an anchor binding the shifting surface of the farm to the earth's core. Like old ledges, abandoned stone walls can anchor our shifting lives to something rock solid, something natural. But unlike ledges, there's a human component to every stone wall. And now my favorite paragraph about time. Emily Dickinson got this entire book, Stone by Stone, in one phrase. The abstraction that gives us Einstein's equation, E equals mc squared, she's as dense of an abstractor in a literary sense. Knowing that human antiquity, these are my words and I'll signal her quote, Knowing that human antiquity is part of something as old as the earth reminds us of the dimensions of time. Stone walls hold time like a set of Russian dolls. The smallest doll, the one furthest inside, contains the oldest things in the universe, the elements. Outward dolls in succession are the minerals composed of the elements, the stones composed of the minerals, the wall composed of the stones, and the modern weathered surface, which is a blend of everything. All of this time is contained in every stone, quote, whose coat of elemental brown a passing universe put on, unquote. Whose coat of elemental brown a passing universe put on. As Emily Dickinson wrote, a stone pulled from an authentic Vermont wall speaks all at once of ancient seas, glacial mud, and the tip of a scythe being broken during spring mowing a century ago. So I wrote the first geology entry to the Encyclopedia of New England. You know, the great big flat, fat book with a blue cover that has a clam on the front? I mean, that doesn't do Vermont right. They ought to have a whalebone for your Lake Champlain that used to be an arm of the ocean. Nevertheless, the encyclopedia, I wrote the first geology entry, and in the presenter's mode, which I can't read, is something like this, that if physical geography, the lay of the land, if physical geography is the place where regional culture makes its home, then geology is the foundation, plumbing, and wiring of that home. In other words, geology is not something that happened or something strong that holds up the landscape. It's active. It's wiring and plumbing. It's hydrology. It's soils. It's all of that. It is not something that has happened. It's something that is happening, probably more rapidly now than it has been over the average. This was a random stack of books that accumulated when I was working on a bibliography. Now that's work. New England is a coherent region. The totality of that region is 72,000 square miles. That seems like a lot. But guess what? My home state of Minnesota is 87,000 square miles. That means all of New England, including the northern Maine, the Northeast Kingdom, and upstate New Hampshire that many of us have never seen, is smaller than Minnesota. And that's not Alaska, it's not Texas, and it's not a little state, it's a middling state, and it's bigger than all of New England. There's a red dot in Worcester, which I'll come to later, but I wanted you to see it. This is Minnesota. It's not a coherent region. It's got hard rock, ancient, exposed Precambrian shield to the northeast where our iron came from that probably built the railroads, that come through Vermont. The north central is just one gigantic spruce bog, the biggest one on the planet, all right? Lake bottom is very much like Lake Champlain to the west. Those are the fertile soils that the Scandinavian immigrants first hit. The Lake Wobegon farmland is the bulk of Minnesota, but there's actually unglaciated, Minnesota in the southeast corner. And Vermont is uniform compared to this. It has the dichotomy of the flat Lake Champlain lowland and the rest of Vermont, but otherwise it's highly coherent. And here is why it's coherent. This is your first ever map of the metamorphic grades of New England, okay? Here they are, okay? The high grade is cordierite. It's basically a mineral that says, ooh, this has really been cooked down in the middle crust of the earth, down to a depth of 15, 20 miles. And the top part is biotite, the bottom is biotite chlorite. That's the lowest grade of metamorphism. That is, if you were to bake a cake, right, and you basically came out sort of marginally cooked on the edges but raw in the middle, that would be the lower grade. And if you burned it to smithereens, it would be the highest grades. And so everything in between is a grade of cooking of the original materials that created the rock of New England. And now I'm going to go back to this page. And what you'll see is that this is a map of the grades. They reach their highest points beginning in northeastern Connecticut and rising right up through the central axis of New England. You see that? There they are right here. That's the axis of the old mountain route. The edge of that old mountain route is right over here. See that? And so what is the grade of Vermont and the Berkshires and the Taconics and all of that? It's low-grade, weak rocks. In other words, they're slates. They're shale-rich or muddy-rich rocks. That's why your mud season is so spectacular. It's because your rocks are low-grade metamorphic rocks. Why do you think New Hampshire is the granite state? It's because that thing was cooked so hard the rock melted and turned into granite at other times. Now, you got some of that too. And here's the foreland. There's also a climatic gradient. So where is Vermont? It's on the backside of that mountain route. All of New England is a mountain route attached to the rest of North America. And the boundary is Lake Champlain, Hudson Valley. Everything to the west is stable, ancient North America. Everything to the east is something new. It's a mountain route attached to North America. There's a climatic gradient here that is driven by north and south, or latitude. And there's a climatic gradient that goes from maritime to dry inland, you see? And this is it. It comes in from the Gulf of Maine. So with those two gradients give you Vermont's position relative to the rest, and here it is. Vermont is basically low grade, strongest grade up to the east. That's where your rocks are the hardest and some of your mountains are the highest. And look where it ends. It ends up here halfway up Maine. That's a very coherent region. So where is Vermont's role in this? This is my favorite word now. This is the take-home word. Do not forget this word, hinterland. Okay? That is my vision of Vermont. If I were to say, what is Vermont's sense of place, it would be the hinterland in the apex of the orocline. Okay? The hinterland is opposite the foreland. The tectonic forces are pushing from this direction, you see? It's squishing all of New England into a giant, colossal, Himalayan-scale mountain range. Really big, okay? But there has to be a foreland, and that's this way. This is the direction of the push, and this is the resistance over here in New York, you see? That's the edge of the continent, and so Vermont lies in what we call the hinterland. It's on the backside of the collision. And when you think about Vermont stone walls, this is what you're looking at. You know, sort of grayish, sort of in the bushes. Nothing like this one. This is on Montauk Point, Long Island, which I consider to be part of New England. Long Island is basically reconstituted northern New England. And by the time you get down there, the only thing that survives are the quartzites. And by the way, you have beautiful purple quartzites in this building. Beautiful. And gneisses and schists. They're beautiful rocks. I don't know where they came from. But by the time you get down there, only the strongest granites and the toughest quartzites have survived that transport distance. And up here in Vermont, these guys are all crushed, you see? So you have weaker rocks that have traveled less far to make it. And so you have a whole different pattern of stone walls, and believe me, that's a whole nother talk. Geographically. Now, I'm saying this as a New Englander. You know, I'm a New Englander. I don't consider myself from Connecticut because it's so small relative to everything else. New England is smaller than my home state, and I moved from Alaska, which is an order of magnitude larger than all of New England, which is a coherent region, you see? So how can, you know, to me, the states of New England are like counties. They're big counties. And I'm not saying that to diminish your sense of place. Your sense of place in Vermont is the best. That's a slide coming up, all right? And it is an achievement. We were talking about this at the table. A sense of place is not a condition, it's an achievement. It's something you make in your brain, your collective cultural brain. And you have done a spectacular job of creating a sense of place in Vermont. New England is my sense of place. I'm not teaching in Burlington. You know, I'm not teaching, you know, at Middlebury. I'm teaching in New England. And I travel all over to do it. So, Connecticut, Rhode Island, Massachusetts, and New Hampshire, all of these places are basically bays or rivers between two highlands. You see that? They're all named. So what happens is this is the name of the place in blue for those states. And then everything else is just out there, you see? Not even settled until after King Philip's War. If you go to Maine, I looked it up again and studied it. Where's the origin of Maine? It's confusing, the name Maine, but it's probably mainland. It's probably a name that originally came to separate the islands from the mainland. Nobody really knows, but that's what I was able to get. So Maine is basically a line. These states are basically a line with terrain on both sides, but Vermont has it right. Vermont is named for the block in the middle, and it has the Connecticut River on one side, and it has the Hudson-Champlain lowland on the other. So the name Vermont refers to the land itself, not to a river that bisects some quantity of land on either side. And I think that's spectacular. And look at it. Look at it. Here's Vermont, right? There's a lowland here and a lowland here, and your name comes Green Mountain State from the land between it. Nominally, you have the best named state. Connecticut is named for the river. Connecticut, it's a native name. It means long tidal river. So Connecticut, the state, the geographic area, the political entity, is really a river. Rhode Island is total confusion. I can't figure it out. Somebody out here might set me straight. But it's named by Adrian Block, either for the island of Rhodes because Aquidneck looked like that, or because they ran into red soil somewhere, and Rhode and red are the same thing. Or it's named for Block Island, which had a patch of red. No, I can't find the name of the origin definitively anywhere. Maybe some of you do. So let's just surrender that to confusion. Massachusetts is named for a native tribe, not a piece of land. New Hampshire is named for an English village, right? So what's Vermont? And Maine is named for the mainland. So what's Vermont named? It's an actual place. So of the 6 New England states, you have the best one nominally. And it's a good one. Green Mountain, yeah, they're covered with forest because they're below tree line, because the latitude is low enough to allow that. Culturally, I think you have the most discrete sense of place, and that's because you're in the hinterland. In other words, you're isolated, and your best access is to the west, in a land being settled from the east, or as somebody said, vaguely realizing westward. That's a Robert Frost poetry, all right? Or as Thoreau said, the direction of the wilderness was the west. So you're opening to the west, not to the east. And if you open to the east in the Connecticut River Valley, you drain down to Long Island Sound, where you're fighting back and forth between New York and Boston, all right? And your affinities are with the St. Lawrence lowland. I mean, Vermont is a French name, so is Champlain, so is your state capital. I mean, come on, this was New France before it was New England. Very, very old. And very west-looking and north-looking, not Atlantic shoreline looking. Makes a lot of sense. And it also is a tightly textured trellis valleys draining to Lake Champlain. We'll see that later. Your claim to fame is mud season. Even that is a geologic explanation. You have deep frost where you expose the soil. Where you don't expose the soil and you leave the trees, you have very shallow frost. But every road and every trail and every cow path, right, freezes deeply because you're far enough north. And you're interior enough to get those crisp January days and December days that deep freeze. And you have what we call argillaceous materials or politic materials. That is, they're basically mud-dominated, clay-dominated. Yeah, you've got a lot of slate here in this terrain, but that slate is basically low-grade metamorphic or slightly pressurized shale. Okay, so it falls apart. The glacier picks up a piece, laughs at it, and it instantly crushes it into a smear that is clay-rich. And you don't get that in most of New Hampshire because that's granite. You crush it, you get a well-drained sand. So, when you take the surface moisture, which is climatically driven, when you take the depth of frost, which is anthropogenic, That is, you create that mud season. There's no mud where you don't go, because it's in your roads and your airports and all of that. And you take the geologic finds and you get it. There. I'm probably nearly done, but I'm just getting started. The full cycle of, so I'll pick up the pace. A full cycle of forestation, deforestation, and reforestation. That's the human component. Superimposed on a full cycle of deglaciation, glaciation, and unglaciation. You see? These are cycles. And that's superimposed on one called denudation, mountain building, and denudation. Denudation is the word for average erosion over an average length of time. Like the land is lowered so many inches, per million years. The whole place. That's what we mean by denudation. Okay, so here is the Geologic Map of Vermont. You can't read it, don't worry about it. The key is it's linear from north to south. Those are discrete geologic units, hard, soft rocks. Down here is a cross-section across that state, you see? And look at it. It's all leaning to the west. It's squished. Okay, so it's a crumple zone. That's what a rug would look like if it was a throw rug and you jammed it against the wall. You're jamming it from this direction to that direction. This is the hinterland of that gigantic, colossal mountain range that's peaking over in this direction. And this is a blob of molten rock rising up from below, and that's the kind of thing that makes the highlands in the Northeast Kingdom. These guys, see those blobs? Those are granite blobs. Denudation is about the soil, it's about the forest soil. Okay? You basically take the you carbonize the air, it drips through there and it rots the rock, and then the rest of the water washes it away. And this is the end result, is not a mountain range, but an upland. If you took the summit of all of your ridges, they more or less, reach some common elevation. Your valleys are entrenched below an ancient erosional surface. Not completely, but especially to the south. Boy, we're getting into the detail. This is an interesting picture to me. Vermont is moated. Not only is it named as the highland, but the glacial lake here is in yellow. You know the name of that one? It's called Glacial Lake Hitchcock. You ever heard that phrase? In other words, it's a moat of muddy, gray water. Beautiful interval lands, terraces and loamy soils. 17,000, 18,000 years ago. 15,000 to 18,000 years ago. And over here, thank you, Coach. Over here, that's Glacial Lake Champlain, or if you like, Vermont is what it's called. Lake Champlain, like Great Salt Lake in Utah, is the small patch of a much vastly expanded lake called Lake Bonneville. Lake Champlain is the tiny remnant of a vastly expanded lake called Glacial Lake Vermont. And basically, with the glacier backing up to the north, if the drainage is to the north, then clearly there's going to be a lake in front of the receding glacier. And it's this big. Look how big it is. And Lake Champlain is this little remnant of it. The key thing is all the terraces and all the deltas and all the shorelines that are the flatland that's producing most of your economy in this region, including Shelburne, is on those glacial lake deposits. Not erosion. There's nothing Green Mountain about them. Okay? In fact, you look at the Adirondacks. And then these are interesting. The glacier backed up the water in these major valleys, you see, producing the trellis effect. Here it is. The glacier's blocking this mouth, so these lakes back up in there. So the best valleys in your Vermont valleys, the best farmlands, are actually glacial lake sediment backed up. And so when the glacier is removed, these gut themselves, they cut down through it, giving you beautiful valleys inside that sediment and building vast deltas in places where you can put airports and hotels and shopping malls. Maybe this is what I was invited to talk about. It was not sure, okay? The land use conversion. This is the Billings Farm Museum. I love this picture. I've used it for years. And the key idea here is that from the U.S. Census in yellow, you got to stop me. Give me a 10-minute warning. Am I past it?
You have 10-minute warning.
Perfect. I can do it. Okay? So everything in yellow is settled before 1700. We're okay with that, right? It's very coastal and only large river valleys. And where is Vermont? Not much. Yeah, we've got some Lake Champlain stuff, but it's not on this atlas at that scale, okay? And everything settled before 1800 is in green. Look at Vermont. Virtually the entire thing is settled between 1700 and then 1800. All of the valleys are being nucleated. And what's happening is guys like this, but a little older, dressed funnier, wearing flax instead of, you know, he's probably wearing flax too. But basically what they're doing is they're taking off the forest. And they're doing an agricultural civilization that I call livestock tillage. That is, they're raising livestock and tilling some soil, but most of it's pasture. Even in the rest of New England. I mean, it's all pasture here, but it's mostly, I mean, not all, but there's tillage. And then up here in the purple, this is everything settled before 1900. You see, so only the Northeast Kingdom, and then even part of that is not settled after that. So this is a crude summary. So the idea is Vermont is hit like an earthquake with people crawling in with their livestock, and they're cutting and cutting and cutting, and they're just going at it rapidly, and then they leave. And here's the slide of them leaving. This is a Harvard Forest publication, but this is the year 1600 is where we are. So this is chronology up to the year 2000 and something. And this is, over here, the New England population. Do you see it? And it's a gorgeous exponential rise. Okay, so for all this talk about arriving and abandoned New England, that's baloney. New England was never abandoned. It simply went from rural to urban. And I looked up rural because I want to know if Vermont is rural. And the answer is yes, by the U.S. definition. Because you know what rural is? It's really nothing. It's the absence of urban. It's like invertebrate, a totally stupid word. You know, because, you know, we're vertebrates and we think we're cool because we're vertebrates. And everything else in life, all 38 phyla or whatever they are, they're invertebrates, okay? So the U.S. government does the same thing. You're either urban or you're not. And if you're not, you're called rural. And that's a great range there. You live in what I certainly live in Connecticut, in ruburbia. It's a contraction of rural and suburban. In other words, if you can go get a cappuccino, you know, and drive to a good medical center within an hour and a half or 2 hours, you know, then you are in ruburbia, even if you think you're living a rural life. No, so rural means a lot of things. It means central North Dakota. That to me. Coming from Alaska, where there's 770,000 square miles, you know, and basically the borough of Fairbanks with 60,000 people where I lived is the size of North Dakota. You know, that's ultra rural. So yes, it's rural in Vermont. Okay, but it's an interesting and I think elegant form of rural. But the key point here is in red. This is Vermont. This is the deforestation. So there's the red line right there, 95% forest when Champlain is sailing around on that lake out there, okay? 95% forest. And look what happens. Very, very little denudation or taking away the trees until about 1800. Do you see that? And look what happens between right around 1800 and the peak down here. It's a little later than Massachusetts, but they're all peaking right around the Civil War time. Look at the rapid carving away of the forest. You went from about 85% forest to about 35% forest in less than a century. And then look what happened. You turned the corner and the regrowth of the forest was just about as fast. To put this in perspective, the Minutemen, and I inverted the diagram because it's a surrogate for population, rural population. Rural population. People walk away from their farms because they don't want to be there anymore. Here's the Minuteman statue. This is that timing. So this is right around, here's Vermont, rise and fall in real rural population. And here's the first rocket launched in 1926. So this is the space age in 1926. Goddard in Auburn, Mass., launching the first rocket. And I'd like to point out that in the background, it's 90% cleared farmland. You see that? So in 1926, you're looking at cleared farmland. 90% of that is now reforested. Much of Vermont has the same story. Okay, so finally, I'm about to give my talk. And I got 5 minutes left, and I can do it, because now you are prepared. I may shorten the readings. This is my latest book. Okay, these are the key pieces. Rock, soil, water, ice, humans. You already know where I'm going because I told you. So I'm going to do at least one of the readings. Taken as one coherent package, New England's bedrock can be crudely visualized as the final result of an intermittent, ultra-slow-motion collision of three supersized tectonic barges against the pier of North America. So you make the rock. Where do you make it? Miles down. That's the key. The rock you see today outside on the beautiful ledges that I saw coming down from Burlington, those beautiful whaleback, smooth bedrock ledges, oh, they're gorgeous. It's nice to see bedrock when you're out in the middle of a lowland, because I think if you see the Earth's crust, you have a better day. Soil. Henry Thoreau is so cool. 61. The first farmer, Thoreau wrote, was the lichen, which plants itself on the bare rock and grows and thrives in cracks until it makes a vegetable mold. Next comes the moss on the surface, starting saxifrage, ferns still green, and huckleberry bushes in the crevices. That's just the way he wrote, just gorgeous. Given sufficient breakdown by all these organisms, you decompose the rock into you-know-what. Soil. And he calls it the forest. From the tops of mountains, the forest appears, quote, like smooth-shaven lawns. And so what's going on under those smooth-shaven lawns is the rotting of the rock and the decomposition, and what happens is the strong rock holds up highest and the weak rock falls down fastest. And when you do that, you carve mountain systems. So think of Vermont's green forest less as a thing unto itself than as an important agency that shapes the land through the creation of soil and then the root mesh that holds it together so that it can go a little bit at a time instead of all at once. Think of the forest. This was a talk I gave last week to the Massachusetts Woodland Institute, like 100 foresters. Okay, that's a different audience, right? Some of them came with their leather pants, you know, fresh from chainsawing. And they totally get that. That to them the forest is a product. I said, look at it as a process. It is a process to me and my students. Woo, we had to blow by that one. Water, 57. I'm going to make it. Initially, the rivers in New England were flowing, they were powerful, and they drained a rocky, rugged landscape like those of Earth's tall mountains today. With time, however, the rivers gradually shifted from being agents of active erosion to being agents of flushing, with the task of sluicing away the waste products of crustal disintegration down to the sea. That is how you carve mountains, green mountains. And now the ice, page 85. I'm really moving along here. The ice in Vermont. Imagine Vermont 20,000 years ago. Above the ice by day was a blue sky, persistently high atmospheric pressure, except during storms. Above it at night was a magnificently speckled, pollution-free host of stars. Biting winds, drifting snow, blah, 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 blah. The scene at the bottom, much harder to visualize, but you're crushing rock and smearing it as a paste to the land, and there is a persistent flow of sand and gravel in meltwater tunnels, and that is where Long Island comes from the Connecticut River Valley lobe in eastern Vermont. The humans. And this is my last one, so I have time to read it. 165. This is Henry Thoreau commenting on the pioneers, but he's also commenting on your pioneers a little later. They were greater men than Homer or Chaucer or Shakespeare, rude and sturdy, experienced and wise people, keeping to their castles or teaming up their summer's wood or chopping alone in the woods. All of that happened here. Those words fit this. Clearing and burning and scratching and harrowing and plowing and subsoiling. Through labor, they plant a town. Through working the land, they plant a town. They rudely bridged the stream and drove their teams afield into the river meadows. They cut the wild grass and laid bare the homes of the beaver, otter, muskrat, and with the whetting of their scythes scared off the deer and the bear. They set up a mill, and fields of English grain sprang up in the virgin soil. That's working the land, but that is the last of, in this case, 5 chapters. There's a picture of a hillside being cleared. Detail I don't have time for, but there is a physical process of clearing that brings up the stones, that thins the soil. It's complicated. You can read about it in Stone by Stone if you like. But the end result is stone walls brought to the surface that would not have been there before. This was not a stony landscape until it was cleared. That's the message of this slide. And here, then, is the final book. And an image, I think, that shows it all. You got to make the rock first. Otherwise, we have nowhere to be. In fact, land is a complicated term. It's more complicated than earth, which means 3 things. Land is a very complex term. After you make the rock, you have to make a forest soil. You can't even do this until the last eighth of Earth history, because we didn't have forests until the last eighth of Earth history. And when you get that forest soil, active biological agents on the surface of rock, you can create enough disintegration, to give you a landscape of the type that we recognize. And then you wash it all away with water, and you do it for millions of years, the sum total of which is called denudation, the uncovering of the land. Then you invade it by ice, then you bring on the human beings, and now you have a landscape that we all recognize. That's the Vermont landscape. And you cannot tell it in less than 5 chapters. Good way to end. Thank you.
Why don't we take a couple of questions? And I think it's obvious when we stop at a rest station in Vermont next year, we will see the new state tagline, Vermont, hinterland of the apex of the oracle.
Any questions?
I have one. What's an oracle line? I didn't answer. Alaska, the picture of Alaska has got the great big curve in the middle of it. That's an oracle line. When you take a mountain system and you bend it, that's an oracle line.
How do you bend a mountain system?
Ooh, that's interesting. I could bend you.
I'm
Okay.
going to give you this microphone so we can get
Well,
Okay, better repeat the question.
the question is, how do you bend a mountain range? You indent it. Okay. If you imagine the mountain range as a sausage, right, that's uncooked, it's flexible, and you just indent it from one side, it'll get a bend. Okay. You can make it bend opposite. It basically it's a compression in XY map view, like this. Okay. Compression like this will squish it together, but if you have an indenter, that is, if you're pressing it all uniformly, you get something that has a tectonic grain like wood. But if one place is getting pushed in further than the others, then that whole grain develops a bend. And I like to throw out a word like oricline, not because I'm, trying to be smart, because I found that it's an interesting way to get people to think about things they wouldn't, because then they want to know the answer. But they didn't want to know it so much that they asked the question. I had to ask it on their behalf. Okay? But you understand it now?
Yeah.
So Vermont is actually pretty straight, but there's a nice curve. Now, actually, New England starts very north-south, you see, down there in Connecticut, the grain. And by the time you get to Mount Katahdin, it's going pretty much northeast, you see? But there's no fault that breaks that, it's just a bend. And the interesting thing to me is that that bend wraps around the Gulf of Maine. So the Gulf of Maine is really the place. It's the continental shelf too, but it's not the Atlantic Ocean. The Atlantic Ocean is too big and too complicated. To me, New England is, there's a Gulf of Maine in the foreland. There's this magnificent mountain route. And then there is the hinterland. And then there is North America. And nothing happened to North America except it got buried with sediments from the rising mountains. But that's where we get fracked gas. Yep. I should have mentioned that.
Thank you. 2 questions.
Good.
1, can we get a copy of your PowerPoint presentation?
Of course.
Okay, and 2,
Whoever we is.
whoever asks, maybe you
Okay,
could
well,
start a
as long as
list.
it's in good
Cool.
faith, yes.
And then my second question, if you can do it in a short time, what accounts for this westward drift that you mentioned in the latter third of your presentation?
Oh my God, you mean the westward drift?
Yeah, just, in 25 words or
of
less.
the continent,
What
of
is,
the land, of the people?
you, in your cross-section diagram,
Oh, that, yes.
you showed a westward drift.
Okay, if you had a room-sized pile of books, okay, of anything, books, blocks of wood, cordwood, okay, and it's room-sized, and you put a bulldozer on that end, right, and a bulldozer on this end, and they drove towards each other, this is what would happen. You'd get compression, but the middle of it would squish upward. It would give you what's called a flower structure. You know what I mean? If you can do it with bread dough, too. You can do it with cookie dough. If you push it all together, you'll notice something that goes like this. In other words, you're squishing it, and it pops up in the middle. Okay? On that side is the foreland. On that side is the hinterland. Okay? The foreland has got more crunch to it, and it's higher grade metamorphic and whatever. The hinterland is just the other side of so that's why Vermont is so cool. It gives you mud season. It gives you green mountains instead of bare mountains. You know, all of those are connected to the fact that it's a clay-rich, argillaceous, fine-grained, slaty rock that is easily laughed at by the glacier and crushed into a paste that's nearly impermeable, and it's fine-grained. You see, so it's rich dairy soils. That's where the dairy come from. If you go to a sand patch, the dairy cows aren't there. It's too dry for them. They want that soil. And that's why Vermont is so, and the part of Wisconsin, the dairy state, that is most dairying, is the part that has the most fine-grained, argillaceous, politic raw materials. We call it the protolith. Whatever it was before. You didn't cook it to the starlight facies. Or gray, excuse me. I forgot where I was. So you get a flower structure. So the idea is that on the hinterland side of a big tectonic push. Now in the case here, it wasn't a bulldozer on either end. It was that continent, North America, sitting fairly stationary, and this guy just coming in like this. So you get a sort of a distorted flower structure that leans westward, you see? And so that's what Vermont is. It's the distorted flower structure leaning westward on the hinterland of the tectonic collision, which I drew an analogy to as a colossal barge just hitting the pier of North America. And the barge is soft enough to squish together and thrust apart into sliced rocks. And that raises another interesting question. Your terrain is so lovely, it's a trellis terrain. That is, there's a linear grain to it, and then there's a cross-cut grain, you see? So you get the grain, all of those are thrust faults. They're little faults, or places where one patch of rock is slicing up against another, so you go soft rock, weak rock, soft rock, hard rock, soft rock. You get hard and soft and hard and soft and hard and soft and hard and soft. And so each one of those is going to give you a ridge. And then you cut that at the oricline, you can bend it, right? And so you get fractures like this, you see? And so your through valleys are following the fractures, and the main valleys are following the ridge lines between hard and soft. And you get this lovely landscape. It's a trellis landscape where you can have high residual peaks
and yet enough flat bottom soil in those northern, mid-Vermont and northern Vermont soils to give you those valley bottom stuff where that you're really building barns. Not building the barns on the side slopes usually until the 20th century. I don't know that I answered your question.
The barge did it.
The barge did it, but basically they're thrust faults leaning westward because it's an asymmetric flower structure.
Against the resistance of the time.
Yeah.
I might ask the last question, then we can continue over coffee. But I revel in talks like this, and it seems like Thoreau and Frederick Church and maybe Jasper Cropsey, mid-19th century writers and artists were also geologists.
They were.
Geologists
They were.
also
Absolutely.
writers and artists. And by the 1960s, well, where did we go wrong?
Okay,
This is
where
my
we
question.
oh,
We're so divorced.
okay,
The
I
conversation.
want to answer this question. It's a great question. I want to answer it. It's what I call cultural geology. Okay, right now it's genomics, right? Everybody's obsessing of genomics and this or that, my ancestry or medical oncology or whatever. It's all about, genes, dating Neanderthals, all of that stuff. I mean, the science of the day is genomics, genes and such. Okay, but think about Einstein's great year in 1805. He got 3 papers together. Physics dominated, that era of the first half of the 20th century. And chemistry and material science, they gave us DDT and also Rachel Carson and all of that. That's coming in the mid-20th century. That was the age of chemistry and material science. You could do no wrong if you were a chemist working at Kodak, for example, or wherever you're working. And so now it's sort of pharmaceuticals, genetics, and then it was, chemical materials. And physics earlier. Well, guess what? Geology was the science of the day in the early to mid 19th century. And it went passé, okay? It went passé with John Wesley Powell going west. I mean, once you go west with all of the exposed rocks, the focus of geology shifted to the American West, to the discovery phase, but it never left here. Emerson's conversion, to being a naturalist, which gave us his book Nature, which gave us the Transcendentalists, which gave us, American nature writing, which gave us an environmental appreciation. All of that comes from a moment when Emerson is in the Jardin des Plantes in Paris, looking at a cabinet of curiosities, minerals, quartz, gold leaf, silver, fossils. Geology was the subject of the day. There's a beautiful book by, I forget who, about geology in the Hudson River School. Just absolutely connected, one-to-one.
Rebecca Bedell.
Yeah, Bedell's book, that's right. So the idea is geology is the subject of the day, and I call it cultural geology, and one of my missions is to bring geology back to the public consciousness. Because when I lived in Seattle, I got the impression that the second graders knew what a geologist was. Maybe 20% of second graders know what a geologist is in Seattle, and it's like 1% in New England. I mean, it went west, but it shouldn't have, because this is where it was really born, in America, and geology was part of that whole literary awakening. And I hope, and let me just finish by saying, I appreciate that last question because it's a theme of mine, and that is that what I want is people, to go back and gather beginning geology and understand that it's the first chapter in a book. Next time you read a book, right, skip the first chapter, right, and start reading and see if the end makes sense. It probably won't, okay? So you've got to go back to the rock, or just read the last chapter. That's typically what people do in the humanities in many ways, is they're programmed and conditioned to read the last chapter. I want you to go back and read them all. And it hasn't, it's not your fault. Our curriculum is insanely scared of fossils. So high school kids come out, they don't even know, what geology is. And it's a cultural, it's a curriculum-driven problem that has to do with democratically elected school boards. And I suppose there's a whole other talk on that.
Thank you.
Okay.